Okay, where do we want to start? Oh no. Oh no. Oh no. Oh no. Oh yeah. 11:15. Or just explain to me how to do 11, and then it'll be easy. Okay. Find the rate of change of the distance between the origin and a moving point on the graph of y equals x squared plus 1 if dx dt is equal to 2 centimeters per second. Okay, so number 11. It mentioned specifically on number 11 that it's talking about distance. So first thing I'm going to do, I'm going to put the distance formula down. D is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. That's a squared. It should be a subscript 2. There we go. Let's plug in some information we know. First thing we know. Between the origin means 0, 0. So that modifies this one step. Instead of x2 minus x1, the x1 is a 0. The y1 is a 0. So we get x squared plus y squared. We also know from the problem itself that y is defined as x squared plus 1. So everywhere there is a y, we may substitute in x squared plus 1. So plus x squared plus 1 squared. Remember, I'm substituting in. I'm not replacing anything besides y. So the y squared becomes x squared plus 1 squared. At this point, I could jump to dd or ddt and start trying to solve this thing. I think that's a terrible idea because I would instead rather take this function and simplify it before I take a derivative. Now, I also know I was supposed to put x in for y and not y in for x because it mentioned specifically dx dt is known. I could have taken the equation y equals x squared plus 1, subtracted 1 from both sides, taken the square root, and gotten this equation instead and done the other substitution. But that's a terrible idea. It is allowable, and for some problems, it's required. Make sure you're reading your problems. Because it specifically mentions dx dt in the problem itself, it is best to leave it the way it is. All right, I'm going to simplify. X squared plus 1 squared, that is a perfect square formula. So d is equal to the square root of x squared plus 1 squared. What is x squared plus 1 squared? So x squared plus x to the fourth plus 2x squared plus 1. I'm going to simplify that one more time before I take the derivative. D is equal to the square root of x to the fourth plus 3x squared plus 1. All right. So the problem says, find the rate of change of the distance. Oh, go back. The rate of change of the distance, as a reminder, rate of change of the distance just means d dt, the change in the distance per time. So my goal is to get that by itself, so that tells me I need to take my next step, the derivative with respect to t. So derivative with respect to t. All right. I'm going to use my u shortcut. That is why I talked about the u shortcut before going into this material. It is very helpful for some of these problems, especially those involving the distance formula, which has a square root in it. What is that shortcut? As a reminder, the shortcut says the derivative with respect to x of u to the 1/2 power is equal to 1 over 2 u to the 1/2 power with a du on top, or u prime. So, is a shorter way to get that function to take the derivative. Let's do it. So, this becomes d dt. All right. On top is going to go u prime. That's the derivative of the inside. So the derivative of the inside, I do it in parts. The derivative of x to the fourth, 4x cubed, dx dt. The derivative of 3x squared would be 6x, dx dt. 1, it would be 0. On bottom, I'd have a 2 appear outside of x to the fourth plus 3x squared plus 1 to the 1/2 power There's dd dt. All right, the question specifically says if dx dt is equal to 2, well, that just means I do a substitution. Anywhere there's dx dt, I plug in 2. So, dd dt. So, on top, we'd end up with 4x cubed times dx dt. That would become 8x cubed. 6x times dx dt. That would become 12x. Again, everywhere there's a dx dt, I replace it with 2. On bottom, 2x to the fourth plus 3x squared plus 1 to 1/2 power. They have not given me a definable value for x. Like they haven't said find it at point x equals 2 or something. It just said find the rate of change. So this is a solution. Now I probably want to simplify one more step. There's a 2 on bottom. I can simplify with the pieces on top. This would become 4x cubed plus 6x over x to the fourth plus 3x squared plus 1 to the 1/2 power. That is dd dt. Apologies. I'm sorry. 4x cubed plus 6x over x to the fourth plus 3x squared plus 1 to the 1/2 power. Apologies. Here's one. Unacceptable. JJ, how could you? Wow. You betrayed me. My savage trust. You know, it's been like 8 years since I had orange juice. Just not anymore. Okay. That was number 11. Questions on other homework problems?
15.
Happily. That will work. 15. Delicious. Possibly going to cause heartburn later. Thank you, old people, OJ. All right. 15. The included angle of the two sides of constant equal length s of an isosceles triangle is theta. So start off with, as is the recommendation on many problems, draw a picture. Okay. We describe some things first. The included angle. Included means between or inside of. So the included angle of the constant equal side lengths. So in an isosceles triangle, that means these two sides are going to be called s. And the angle between them. It's important to note that this angle could be changing. Meaning that, I'll try to draw it, but it's going to get a little messy here. It could be getting bigger. But even still, the sides are still going to be s. But the angle got bigger to compensate for that. And so depending on how big the angle is, that could affect how big the area is. If the angle is very small, obviously the area is going to be very small. If the angle gets bigger, the area will eventually get bigger, and eventually it gets too big, and it starts to stretch out and get flattened out and become, again, very small. So, show that the area of the triangle is given by A is equal to 1/2 s squared as sine theta. All right, ready? With this picture in mind, I'm going to set the problem. Okay. Going back to my basic picture. S, theta, boom. How would I find the area of this triangle by standard geometry? What do I look for? Or in other words, another way to say that. What's the normal formula for the area of a triangle? 1/2 base height. Now in this picture, there's a problem. The base would be down here. The height would be down here. So if I could find h, if I could find b, I'd have this problem solved. So how could I go about finding h or b?
Split it up into two right triangles.
Split it into two right triangles.
Yes.
Okay, let me do that. Okay, if I do that, some of the pieces are going to change. Let's call this the left-hand side. What number is going to go out here on the left-hand side? Still S. What number is going to go down here at the bottom?
Base over 2.
Base over 2. Not just the base, base over 2. On the right-hand side? H. And in the top corner?
Theta, or
Half theta. And down here, a right angle symbol. Now, I need to somehow figure out how to put B and H in terms of two things that do have S and theta. I know this is the right path because they told me the answer. The answer is supposed to be a combination of S's and thetas. Right now, I have B's and H's. So if I could find some way to rewrite B as some combination of S and theta, and H as some combination of S and theta, then all I have to do is just plug them in, and I should be able to get to my solution by some simplification. There we go. Looking at this picture, if I do sine of theta over 2, be B over 2 over S. If I do cosine of theta over 2, which is the other suggestion you made, what would it be? H over S. So, I now have two formulas that contain either B or H as well as S and theta. But I want this formula to be replaced by pieces of just S and theta. What would I have to do to this function or to the bottom function to make it happen? Not S. Solve for H.
Yes.
So I multiply both sides by S. I end up getting H is equal to S times cosine of theta over 2. Which I can now plug into that formula, give me 1/2. That's awful. Giving me 1/2. I want to leave some space for B times H. Well, instead of H, I'm going to write S cosine theta over 2. Looking good. I'd probably want to solve for B as well. Walk me through that. How would I solve for B? Multiply by S. That would get me close. I'd have B over 2 equals sine of theta over 2 times S. Multiply by 2. So B would be equal to 2 times S sine of theta over 2. And you better believe it's real annoying having S in this problem. Okay? So now I've got B defined as well. I can plug that in. So I've taken H and plugged it in. I'm now going to take B and plug it into this formula. So that would be 2 S sine of theta over 2. Okay. Well, let's do some simple things. The 1/2 and the 2 are going to cancel. The S and the S are going to become S squared sine theta over 2 cosine theta over 2. So this tells me the area should be equal to this function. But that is not what they said in the problem. What they said in the problem is, I want to get this version instead. I'll bet there's some trig manipulation I have to do to get this to pop out. So let's take a second. I'll be honest, I don't have all the trig formulas memorized. When I work on calculus problems, I have a piece of paper next to my desk that has a list of all the trig identities. Why? I don't want to have them memorized. Okay? So, I'll bet there is a trig identity out there that converts the thetas over 2 into something else. Luckily, here are my trig identities. Good luck.
Oh, my folder didn't work and I lost it.
Also go to Google and just type in trig identities and it'll pop up a big list. There's got to be one. So give yourself some hints, okay? We start with theta over 2. We don't want theta over 2, so we're probably going to look for something that's a double angle formula maybe, or half angle formula. Cosine of theta over 2, same thing. There must be some conversion I'm missing that will rewrite these two. Or maybe I just find one that uses sine times cosine in some way and rewrites it. There's got to be something, okay? We'll take a look at that list of formulas. I have to somehow rewrite s squared times sine of theta over 2 times cosine of theta over 2 as just 1/2 s squared sine theta. I'll give you a hint. It's either in the half angle formulas or the double angle formulas. Look for something with sine times cosine to give you a hint.
Okay,
What's it say?
This is sine of 2 theta is equal to 2 sine theta cosine theta.
Wait, hold on. Say it again.
Sine of 2 theta.
Of 2 theta, not squared theta. Sine of 2 theta
Equals 2 sine theta cosine theta.
Okay. Now I'm going to make a small change here. Instead of theta, I'm going to use x, because I don't want to confuse the theta of the problem with this theta. So instead of theta, and theta, let's say sine of 2x equals 2 sine x cosine x. All right. I see sine times cosine. That's a good head start. If I assume that x is equal to theta over 2, watch what happens to this formula. This would become sine of theta is equal to 2 sine theta over 2 cosine theta over 2. Well, that's looking real close. But it's got this 2. So I move that 2 over by division. I get 1/2 sine of theta is equal to sine theta over 2 cosine theta over 2. Now I do a simple substitution. Anywhere there is a sine theta over 2 times cosine theta over 2, I replace it with 1/2 sine theta. Woo-wee! So right here, all of this is replaced by s squared times 1/2 sine theta, which of course is the answer they expected. 1/2 sine squared, s squared sine theta. I'm going to do that like 50,000 times. Exactly as we expected. So in this case, we used 2 trig identities, the sine identity and the cosine identity. We used a different trig identity, which I believe is the double angle identity, right? It was, yeah. To rewrite it, to get it in the formula it expects. This is not saying that this formula isn't true. This formula is true. But they asked you specifically for a different formula, so we made some modifications to it. This is standard modification, where I take one that is given in terms of theta, use a different variable, and then substitute something in. That way I get it to work better. Because they're all the same. Questions? 15. Or A. Coolio. Do you want to do part B or part C?
I think we're fine
Yeah.
with that.
Okay. I assume you're able to use part A's solution to get part B and part C without needing to prove part A. That's the nice part about them giving you the answer. Okay. Others. We have 7 minutes, 8 minutes, 9 minutes. A little weird.
Oh, okay.
21?
No, I got 21. But we can't do 21.
I'm here. I could sit here and dance the lollipop dance. Like,
Do it.
no, I won't.
Oh.
Fat man spinning is not something that goes on Broadway.
Yeah, I know it. We'll do 21.
21? You could do one you haven't done yet. You know.
I mean, I
If you want
haven't
to.
said 21.
Oh. 21. At a sand and gravel plant. Yes, they do exist. They take big rocks and they break them into small ones. It's cool. Sand is falling off a conveyor and onto a conical pile at a rate of 10 cubic feet per minute. The diameter of the base of the cone is approximately 3 times the altitude. At what rate is the height of the pile changing when the pile is 15 feet high? Let's start with what we've talked about so far. Taking the information in the problem and turning it into mathematical text. Sand is falling off a conveyor and onto a conical pile at a rate of 10 cubic feet per minute. Give me what those statements mean. What do they tell me? How can I use that information? What is something we've learned from it saying it's a conical pile at a rate of 10 cubic feet per minute? We know not dVdt. We know dVdt. And what is dVdt?
Volume with respect to time.
Right? And that's given in the problem. What is it? 10. In this case, cubic feet per minute. Right? What else in that first sentence might be useful? Anything? Shape of it, right? It's a cone, right? And because it's a cone, and we're dealing with volume, we also should probably talk about the volume of a cone. Do we have a formula? Perhaps from an earlier problem?
One third pi r squared h.
No, pi r round. Never gets old. Never in my life has it gotten old. Okay, let's keep reading. Information we've used so far. So it's a conical pile, cubic feet, that's good. The diameter of the base of the cone is approximately 3 times the altitude. What does that mean? The diameter of the base of the cone is approximately 3 times the altitude. Yeah. So the diameter, which we call d, is equal to 3 times the height. Cool? That's the second sentence. At what rate is the height of the pile changing when the pile is 15 feet high? Say again? H is 15. What else? What are we looking for? dH dt. This is really important for this problem that I know I'm looking for dH dt. Because remember, I can choose which variable to solve this equation for. Because remember, for the variable equation we have 1/3 pi r squared h. I can do it with r, I can do it with h. I got to pick one. But dH dt tells me I should probably do it with respect to h. Okay, all the information is on the board. Walk me through our first couple steps. I wouldn't. Not yet. Could draw a picture. Good place to start. Could do some substitutions. I'm going to start by drawing the picture. I know you're impressed. Okay. we have the height, we have the diameter. We know that the diameter is equal to 3 times the height. So far, our picture's pretty good. Now, your recommendation, Abby, was to rewrite this in some substitution. I 100% agree. It is best to get this in one variable at the start if I can. Because of this statement, I know eventually I could. So I'll start there. How am I going to do my substitution? What am I going to substitute? How will this formula change? Good. We don't want D, we want R. So remember, D is equal to 2R. So we can divide to get R by itself. R is equal to 3H over 2. Plug it in for R. V is equal to 1/3 pi. Instead of R, 3H over 2 squared H. Why did you do it this way? Why specifically did we divide by 2 to get R by itself instead of dividing by 3 to get H by itself? What hint gives us that information? We have H. H is 15. But we could easily find D. Just plug it in. That's not a good enough reason. It's not good enough. We want specifically to find dH dt. This is reason enough. That's why. Okay? Which I only get by reading this last statement correctly. What is the rate of change of the height? Well, rate of change of height is dH dt. Okay, now I recommend we can take a derivative pretty well, but I'd probably simplify first. Strong recommendation. Are we through it? 9h squared over 4. Good. So we'd have V equals 1/3 pi 9h squared over 4h. We're just going to leave it like that? Okay, simplify the 1/3. What else? If you want to just call it the solution, you can.
Oh, wait, you want me to tell you first?
Yeah.
Oh, 3h squared over 4, right?
This becomes pi 3h squared over 4. No, I wouldn't. Fundamentals. H squared times h. Pi 3 over 4. H squared times h would be h cubed. Fundamentals. I apologize for continuing to go to the bottom of the board, Sydney. I'll put it up here for now. Okay, now is a good time to take a derivative. If I did it before this point, I could take the derivative at any point in time, but each one is less ideal than this one. Because up here, yeah, I could do it, but I'd have to do a chain rule times the product. Here I'd have to do just a product times a product. Here is still a product times a product, and now I have just a power rule. It's much easier if I do it from here. All right, let's do it. d dt. Left-hand side. dv dt. dv dt. Right-hand side. Pi is constant, so it stays.
4/4 times H.
I want to double check that, Ricky.
1/4 H cubed.
I want to double check that, Ricky. So what happens with 3/4?
1/4.
Nope. Multiply by 3x squared. Or 3h squared, I should say. Times dH dt. So let me try to make this a little better here. dv dt. You are dividing instead of multiplying. See what it was? This would be 3 pi over 4 times 3h squared times dh dt. Plug in 10 for dv dt. 15 for h. So 3 pi over 4 times 3, 15 squared dh dt. And I assume from there you guys can divide by yourselves. There we have it. These ones, like I said, will push your fundamentals on the derivatives really far. It's just because, it's a lot of steps. Related rate problems become the marathon of calculus. These are some of the longest problems in this class period. And like with a marathon in real life, a lot of people can run 100 meters. Fat man me can run 100 meters. I ain't making it at the end of the marathon. It's about endurance, about having that training. And making sure to stick at the line. Alright, we're out. I will accept these Monday. I will not be answering questions on Monday, though. We'll be reviewing our tests. So. Yes. Remember, your final is required for this class. It is AP.
We're starting like the test earlier.
Yes.
Are you?
No.
Hey, what's that?
Huh?
Oh my God.
Your dad's looking at me, Joy?
Good.
That's the computer side.
How much
I know that game.
$120.